Hello and welcome. In this lesson, I'm going to solve a few questions about area of circle. So, my first question is that ABCD is a rectangle. A and B are centers of two circles. AB, which is AD, AD is 6 centimeter, which is this one. So area of shaded region, which is this part. So to calculate area of this shaded region, we need to find the area of circle and area of quarter circle. Then you need to subtract from all the area of rectangle. So if this one is 6 centimeter, this is going to be 6 centimeter too. Now this is a circle, that means this is a radius. So radius, this 6, this should be 6 too, and from there this end is the same thing to 6. That means AB is going to be 12 centimeter. Now you should remember that area, the formula of area of circle is pi r square. Okay, from there I see the quarter circle, and the circles are the same. So that means quarter plus quarter is going to be half, semicircle. So semicircle means half of the area of whole circle. That means the area of this plus this is going to be pi r square over 2. As for my, this is not shaded region. Then I need to find area of rectangle. So area of rectangle is height times base. Height is there 6 and base is 12. So that means 6 times 12, which is going to be 72 centimeters square. Alright, I see the r square radius. Radius is 6. So what I told you, I said you are going to find the area of this two part and then subtract from area of whole rectangle. Area of whole rectangle is, let's write the area of shaded region equals to 6 times 12 minus pi times r square. R is 6 square over 2. So then I'm going to calculate this part, which is going to be 72 minus pi times 6 square is going to be 36 pi over 2, and I can simplify this by 2. That's going to be 18, that's going to be 1, which is 72 minus 18 pi, which is going to be your final answer. See, area of rectangle minus area of this 2/4 circle, which is going to be semicircle, which is half, and then there is going to be 72 minus 36, simplify 18 times pi. Alright, this question is really cool question. So the question is saying that P, B, C and K are centers of 4 circles. So AB, BC and CD are the same and 4 centimeter. See, look at the cool question. It's very cool, I tell you. So, right, what we do now there. Normally, students are confusing this question too much. They try to do too much complicated things, and they confuse the question solution, and they find wrong answer. So, look, I'm going to show you very easy thing from that question. The first thing, you can calculate area of this big semicircle first, this top part, and the area of the semicircle. Then subtract this not shaded region from this big semicircle, and you will find the shaded area for this part. And you do the same thing for that one too, and then you add to each other. But if you notice, see, AB, BC, and CD are the same. See, AB, BC aren't they radius of for the big one, big circle? And the same thing for this one, BC, CD. These are the radius of the big one. That means this semicircle and this semicircle are the same. So therefore, okay, there and this radius of the small one, that will be 2 2. See, this one the same thing, 2 2. That means this and this are the same thing too, the same circle. So instead of doing that half and half separately and then add to each other, cut this bottom shape and turn it around like that, then stick under the shape. That will be something like this. Look, and the shade area is going to be this part. So what I got one big circle and one small circle, and you see this is not shaded, so I will find the area of this and area of this circle, then subtract the area of this one from the big one. Let's do it. And remember, the area formula of area was pi r square. So now for the big one, that's going to be pi r square is 4. So 4 minus, and the small one, pi r square, which is 2. Pi times 2 square. That will be for the shaded area, shaded region, 16 pi minus 4 pi, which is going to be 12 pi. That's going to be your final answer. Alright, another cool question is there. ABCD is a square with perimeter of 64 centimeter. So what is the area of shaded region? So to calculate the area of shaded region, we need to calculate area of those not shaded region and subtract from area of square. There I see perimeter of square 64. I have 1 2 3 4 equal sides. So let's say x for one side of square, that will be 1 2 3 4x equals to 64. From there you will get x equals to 16 centimeter. That means one side of square is 16 centimeter. So then I see this one is radius of the small, and there all of them are the same. So this is radius, this is radius, and this is radius. If you see there, 1, 2, 3, 4 radius, and this part was what? 16 centimeter, because one side of square was 16 centimeter from there. So 1, 2, 3, 4, 16 divided by 4 will be 4 centimeter, the radius of circles. Now the area of square is going to be, let's say, area of shaded region equals to area of circle, 16 times 16, height times base, 16 times 16 minus pi r square for the one circle times 1, 2, 3, 4. So pi times r square is, r is 4 radius, and times 4 of them. So this 4 is radius of circle, and this 4 is number of circles, right? There are 4 circles. So then that will be 16 times 16, which is going to be 256, minus, that will be 4 times 4 square is going to be 16. So now 16 times 4 is going to be 64 pi, and that's going to be your answer, final answer. Sometimes you are not going to see this one in option. What do? You take this 64, and from the 64 out, that will be 64 times, this one is 64 times 4, will stay there, 4 minus, and the 64 came out, which is going to be pi. This will be 64, open the bracket, 4 minus pi, which is going to be your final answer. Alright, so you will see definitely one of them in option. Alright, I hope you found questions, so all of them so cool. So thank you so much for watching. Please don't forget to like and subscribe.